So in this lesson, we're going to be covering the basics of addition and subtraction with fractions. But first of all, we have to think about normal addition with regular whole numbers. So in this case, of 14 plus 23, when we do this addition, we do 4 plus 3 is 7, 1 plus 2 is 3. That gives us an answer of 37. But if you notice while we were doing this, if we looked at our tens and units columns, we had to respect that the 4 and the 3 had to be added together, we didn't do any cross addition, we didn't do 4 plus 2. So the reason for this is if we look at what the base representation of those numbers are. So the 4 in the 14 is a unit, this 3, the 23 is also another unit. So they have to be added together, that's why you cannot add diagonally. And so that's why when you add two units together, you still have to add the unit underneath. And so you respect the columns that they're in. This rule works exactly the same for when you do the addition of fractions. So we think of the top number as the multiple. So in this case we have 1 lots of something over 4, and here we have 2 lots of something over 4. And on the bottom, that's what you consider the numerator, or the base of our fraction. So fractions can only be added if the bases are the same as each other. So in this case, this question can be answered 1 over 4 plus 2 over 4. So same way beforehand, in our normal addition, where we were looking at the units column, and we had an answer that was also in the units column, the same will apply to our fraction. Because the base of both of these numbers is over 4, our answer must also be 4 in the numerator spot on the bottom. Now we have the base sorted, we can just look at the top and think, well, we have 1 lots of our fraction here and 2 lots of our fraction. So 1 plus 2, it's going to give us 3. So we'll do another example. 1/5 plus 2/5. Again, we can see that on the bottom half, they're both divided by 5. So that means that these two fractions can be added together, and the answer will also be over 5 for our fraction. So now that's been sorted, we look at the top, and we just add the top half of our fractions together. 1 plus 2 gives us 3 for 3/5. What happens though if we have an example where the bottom half of our fractions don't equal 2/3 plus 1/7? So at this point we can't just add these two numbers together straight away because their bases don't match to each other. So we have to manipulate this fraction in order for us to allow them to multiply. So for us to solve the original question, which was 2/3 plus 1/7, we need to be able to manipulate this fraction to mean something else. We need an equivalent fraction. So if we take the example of 1/2, if we draw it out, we can see if we took a circle, the number on the bottom shows how much we split the circle into. So in this case we split it to 2 halves. And the number on top is just how many multiples of that we have, so one section. Now, if we were to multiply both the top of the fraction and the bottom by the same number, so in this case we're going to multiply both top and bottom by 2. So 1 times 2 is 2, 2 times 2 is 4. So these are equivalent to each other, they mean exactly the same thing. And if we draw this out, so we're going to divide our circle into 4 equal parts, and then we're going to select 2 of them. You can see that they give exactly the same representation, so that proves that the 2 are equal. So how does that help us with our original question? Well, what we need to do is somehow change the base, 3 and 7, to be the same number as each other. So the quickest method to do that is to multiply them each together, so that will give us the lowest common multiple of the two numbers. What does that mean? Well, 3 times 7 gives us 21. 21 therefore has to fit into, is a multiple of 7, and it's also a multiple of 3. So how do we get there for each of these two fractions? Well, let's start with 2/3. Well, in order to get the base up to the number 21, we have to multiply by 7. So in order to keep things equivalent, we do the same to the top number. We also times that by 7. What does this give us? 2 7s are 14, 3 7s are 21. So that's one of our fractions moved around. Let's do the other one, 1/7. How do we get 7 to 21? Well, we have to multiply by 3. And same again, we do the same to the top. And now that gives us an equivalent fraction of 3 21s. So this is what it's meant by finding the lowest common multiple when it comes to manipulating fractions. You want to multiply the two bases together, and that will tell you what your target denominator should be. In this case, 3 7s are 21. And then to each of our fractions, we then have to multiply them by whatever number it is to get us to that. So what this looks like, if you just look at the question on its own, is that you multiply your left-hand fraction by the right-hand base, and you multiply the right-hand fraction by the left-hand base. So now we rewrite this out. 2/3, when we multiply both top and bottom by 7, that 2/3 becomes 14 21s. And we multiply the right-hand side by the left-hand side denominator. 3 times 1 is 3, 3 times 10 is 21. So you can see a bit clearly now what we've done is that we've converted both of these fractions into something over the same denominator. Now we can add these two together, because they both have the same lower number, the same base. So because they have a base of 21, our answer will also be over 21. 14 plus 3 is 17. And that's our answer. So we'll try another example, 1/5 plus 2/3. So what we're going to do, we're going to convert these into, because these two can't be added together because they've got different bases, we're going to convert these into 15ths. So we're going to multiply the left-hand fraction, top and bottom, by 3. So 1 times 3 is 3, 5 times 3 is 15. And the right-hand fraction, we're going to multiply this by the left-hand denominator. So 5 times 2 is 10, and 5 times 3 is 15. Now that both are in the same denominator base, they can be added together. And you just add the tops together. 3 plus 10 gives you 13. And this was exactly the same way for subtraction as well. Five sevenths minus 1/4. We do exactly the same method as before. So the left-hand fraction, we're going to multiply by the right-hand denominator. So both top and bottom, 5 times 4 is 20, 7 times 4 is 28. Then subtract, and our right-hand fraction, now we're going to convert this to an equivalent fraction by multiplying top and bottom by 7. So 7 times 1 is 7, 7 times 4 is 28. And now we do subtraction. The denominator is still going to be over 28, because remember we've always got to keep the same base going through. And then 20 minus 7 is 13. So in this example we could do the same method again, 5th plus 3/10. So we can multiply the left-hand fraction by 10 to give us 10/5, 10/50. And then the right-hand fraction we're going to multiply by 5 to give us 15/50. Now, that's one way, that's using the original method. But what we could spot here is that the only reason we're manipulating the fractions at all is just to get the bases to be the same as each other. So you can just multiply the two together to get 50ths. However, what you should be able to spot quickly is that 10 is a multiple of 5. So there's no need to change both fractions, we can just change the left-hand side. So if we wanted to change a 5th into something over 10, we have to multiply both by 2. Because if you think what we're trying to do, we're trying to convert 1/5 into something over 10. So we can see we just need to multiply the bottoms by 2. Well, no, 5 by 2 to give us 10. And so to make sure they're equivalent, we have to do the same for the top. 1 times 2 is 2. So that gives us, we write it out immediately now, 1/5 converted into a 10th, so we multiply top and bottom by 2, that gives us 2/10. And then we just bring down the right-hand fraction, because that's already in the base that we need it to be in. Then we just add 2 together, bases will still be in tenths, 2 plus 3 is 5. So now a question for you to practice. 2/20ths plus 2/5. Do you want to give the video a pause and try this one for yourself? Okay, so the answer for this one. So we can spot quickly that 20 is a multiple of 5. So because of that, we only have to change the right-hand fraction. So, how do we convert 5 into 20? Well, we're going to have to multiply by 4. So let's do that for both top and bottom. 2 times 4 is 8. 5 times 4 is 20. Bring our first fraction down. So that's just 2/20ths. And now the two can be added together. 2 plus 8 gives us 10. And on the bottom, it's just going to be the 20 still. Now this is not quite complete, 10 over 20, because it's possible to write this as something smaller. So with equivalent fractions, so far we've just been making the two fractions equal to each other by making them large by multiplying them by various numbers. But we can do the same in reverse. We can make 10/20ths smaller, and the thing we should recognise is that they both, well, one is the multiple of another, or at least they share a common multiple. So in this case, 10/20ths, what's the multiple that they share? 2 is a simple one, because they're both even. So what we're going to do is divide both top and bottom by 2. So what does that give us? 10 divided by 2 is 5. 20 divided by 2 is 10. So what we managed to do is make our fraction of 10/20ths smaller and say it's 5/10. But we can go further still. Because 5 and 10 both share another common multiple. They both share a multiple of 5. So we can divide top and bottom by 5 again. And what does that give us? 5 divided by 5 is 1. 10 divided by 5 is 2. And now notice we have a prime number here, the number 2. So this is as small as it can go. As small as this fraction can be. So that means our answer to 2/5 plus 2/20ths plus 2/5 is actually a half. Now, it is the same. Those two numbers, 10/20ths and 1/2, are both the same. But in fractions, we always want to write it as small as possible. Use the smallest numbers we can. So with that being said, one of the things we should practice now is just simplification of our answers. So more practice when it comes to simplification of fractions. Say we came to an answer of 12 over 60. We want to make this small as possible. So we can spot that the number 2 divides into both of our numbers. If we do that, we get 6/30ths. And here we can see that 2 is again divisible into both these numbers. So that will give us 3/15ths. Can this go further? Yes, because 3 fits into both of our numbers. We do that division, and we're left with 1/5. And this is the smallest you can make this fraction now. But what we can spot at the very beginning is that we could have used a larger multiple to start with. So instead of dividing top and bottom by 2, we could have divided top and bottom by 4. 12 divided by 4 gives us 3. 60 divided by 4 is 15. And then we could have gone and divided top and bottom by 3 to give us 1/5. So we've saved ourselves a step here. But it's possible to do this even faster. Because 60 is a multiple of 12. So we can divide both of them by 12 to jump straight in and give us 1/5. As you can see, in each case, no matter what path we took, we always got the same answer. But it's always best, if possible, to use the largest multiple you can first. Saves you having to do more steps and less chance of making a mistake. So for another practice question, let's do 5/14ths plus 1/2. We give the video a pause again and give this one a try. So the answer for this one, we can see that 2 is a multiple of 14, so we're just going to increase the right hand fraction. There's no need to change the left hand one. So to go from 2 to 14, we have to times top and bottom by 7. So the equivalent fraction to a half is 7/14. On the left hand side, we just bring that fraction straight down. So now that both our fractions are the same base as each other, we can add them together. 5 plus 7 is 12. And then carry the bottom fraction together, we get 14. Now that we can see that 12/14, they both share a common factor of 2, so this can be made simpler. Divide on top and bottom by 2, that gives us 6/7. And now there's no 6 and 7 don't share a multiple, so therefore this is as small as the answer goes, and that's your final answer.